Water has no color, right? So why do things look darker when they get wet? I guarantee you'll never look at rain the same way again. You'll see this everywhere. Wet pavement, wet hair, wet sand, soaked clothes, oiled wood, pretty much everything. Except, weirdly, glass, mirrors, and polished metal. If you're thinking water carries dirt with it, or that it has some kind of tint that darkens things, you're wrong. Completely clear, transparent water shows this effect too. This isn't about chemistry at all. It's about something completely different. Light. Why dry things look bright? See, most everyday surfaces, pavement, fabric, sand, paper, wood, are microscopically rough or porous. Zoom in close enough and they're full of tiny air pockets and fibers. Each of those acts like a tiny mirror, scattering light back toward your eyes. The more light that bounces back, the brighter something looks. Light bends and reflects whenever it moves between two materials with different refractive indices. Stick with me. This explains literally everything else in this video. Air sits at about 1.0, while most solids sit between 1.4 and 1.6. That's a big jump, and big jumps mean more light bounces straight back instead of going in. But when water sits in between, it adds an extra step. Water's refractive index is about 1.33. So now it's two smaller jumps instead of one big one, and more light gets through. Okay, but where does the light go after entering inside? That light doesn't just disappear. It bounces around inside, hitting fibers and mineral grains, losing a little bit of its energy with every bounce. Some of it tries to escape back out, but the water's surface acts like a mirror and reflects part of it back in. A little light does make it out, just not enough to make the surface look bright anymore. Think of it as a pit in which our balls get stuck. I mean to say playing balls. This trapping effect has a name, total internal reflection, and it's the exact same trick that lets fiber optic cables send light and your internet for miles without it escaping. In a wet surface, that same trick is what keeps light bouncing around inside instead of escaping back to your eyes. But here's the twist. The exact same puddle can be the darkest thing in a photo from one angle and the brightest thing in the photo from another. Nothing about the puddle changes, only where you're standing and where the light is coming from. That's because here, the puddle itself becomes a mirror. It's not just a wet surface anymore. It's a layer of standing water. Look at it from a different angle, and you change how many of those reflected rays make it into your eyes. Now take a look at this. Why did the color change from white to gray? As the snow is made of countless tiny ice crystals with tons of air gaps between them, light hits all those air-to-ice boundaries, jump from 1.0 to about 1.31, over and over, and bounces back out in every direction. That's why snow looks so blindingly bright and white. Now when it starts melting, water in the form of liquid fills those gaps. Oh, and remember how I said this doesn't happen to glass, mirrors, or polished metal? Now you know why. Those are already smooth. There's no rough, gappy surface for water to fix in the first place. No gaps to fill, nothing changes. A question for girls. Do you know why you start looking beautiful, even when you are not, after applying products like gels, lip glosses, and sealant? See, oil has a refractive index of 1.47, meaning more closer or greater to the solid, 1.4 to 1.6. Therefore, the oil layer over a surface makes it look darker, richer appearance. This is why oiled wood, oiled salad, or oiled skin looks noticeably more saturated and glossy than the same thing wet with plain water. Coming back to the beauty products, they use this physics to make you beautiful without actually making you naturally. It's just a way to get a temporary beauty. And this all ties into a major discovery. Before the 1930s, camera and telescope lenses were made of glass with a refractive index around 1.5. Still a big jump from air, which meant a lot of glare. Then, scientists discovered that a thin coating with a refractive index between air and glass could dramatically cut that glare down. It was such a big deal that it was treated almost like a military secret. Remember that rock from the start? Same exact thing happened to it. Light got trapped inside instead of bouncing back out to you. Nothing was added, nothing changed, except how much light made it back to your eyes. Next time it rains, try this. Look straight down into a puddle, then walk back and look at it from far away, close to the ground. You'll literally watch it flip from looking like a black hole to a mirror. It's kind of trippy. Try it. Now, I think that you'll look at the next rain more closely and enjoy how beautiful our nature is without any products. Signing off.